Dear students, I am going to explain very important part of this chapter, and it is azeotropes. Azeotropes, or they are also called as constant boiling liquids. So azeotropes may be defined as the liquid mixtures or the solutions which boils at a constant temperature without any change in concentration. It means when we boil such liquids, there is no change in concentration. Concentration remains as it is. Concentration remains as it is, irrespective of our boiling, or we heat them or we boil them. So, azeotropes, actually, children, azeotrope is a Greek word and it means constant boiling liquids. So, azeotropes are the solutions, or we may say liquid mixtures, which boils at a constant temperature, or they have their own boiling point or a particular temperature without undergoing any change in concentration. So the point is their strength remains same irrespective of the time period for which we boil. So, or we can say, or their strength remains the same. Actually, azeotropes have a particular tendency, and as a result, there is a very strong or very weak force of attraction between different particles, that is solute and solvent. Now I am going to explain the classification of the azeotropes. So azeotropes are of two types. Azeotropes are of two types. So classification, there are two types. First is minimum boiling. Minimum boiling azeotropes, and second, maximum boiling azeotropes. So we'll take up one by one that what is the reason behind their tendency, that in first condition it boils at minimum temperature. So minimum boiling means it boils at a minimum temperature, and maximum boils means it boils at a high temperature. So now we'll take up one by one with their regions and their examples. Now minimum boiling is dropped. So they are the binary solutions. They are the binary solutions. Binary solutions means the solutions made up of only two components. Binary solutions which boils at a lower temperature without undergoing any change in concentration. The concentration remains same. And actually, you know about the Raoult's law. You have the negative deviation and we have the positive deviation. So they The minimum boiling isotopes, children, they have the uh, resemblance with the solutions showing positive deviation. So they resemble with solutions showing positive deviation. Positive deviation in case of non-ideal solutions. So there is the positive deviation. So as you know, positive deviation means the vaporization takes place easily or vapor pressure is exhibited at low temperature. That's why there is the experience of the vapor pressure at low temperature. Now example, ethyl alcohol, and water. Around it is 95.4% by mass, and it is 4.6% by mass. So they boil at low temperature. So point is, what is the reason behind it? Actually, as you know, the positive deviation. So it means the force of attraction between, suppose we take the ethanol or ethyl alcohol and water. So here the evaporation takes place at low temperature. It means the force of attraction is something different with the ideal solution. So here the force of attraction between the ethyl alcohol and water molecules. So we say the poor attractive forces. So as the attractive forces are poor or weaker between the solute and solvent molecules, so as a result, they are vaporized easily. And so both the components, they contribute each other independently, and as a result, the solutions starts boiling at low temperature, because as there is the positive deviation, so there will be the elevation in the vapor pressure. Vapor pressure will be elevated, and so such solutions will start boiling at a lower temperature. And so this is about the minimum boiling isotopes. Now, second is maximum boiling isotope. So children, as name indicates, maximum boiling, it means they are not converted into vapors, or the binary solutions which are not converted into vapors easily, and so they need more temperature. So maximum boiling isotopes, they are the binary solutions which boils at higher temperature. They boils at higher temperature than that of the certain value without change in composition. The composition remains same as it is in case of the minimum boiling. So, for example, there are several examples like HNO3, HNO3 and water, H2SO4 and water. So they exhibit the maximum boiling nature. And again the reason same. As in case of minimum boiling, they are able to undergo vaporization easily. They exhibit vapor pressure easily at low temperature. That's why they boil at low temperature. But here as it is maximum boiling, it means the forces of attraction between the molecules will be much more. So we can say here if we take the HNO3 and let the water. So here the attractive forces are stronger. Attractive forces are stronger. So actually they are type of non-ideal solutions having negative deviation. So they resemble with non-ideal solutions. Non-ideal solutions having negative deviation from ideal behavior. So they have the negative deviation. It means the forces are stronger and we have to use high temperature. You have to heat more and more. It means high temperature has to be supplied, and so this is there. Again, we can have the diagrammatic representation. So diagrammatic representation will remain the same. Diagrammatic representation will remain the same as it is in case of the non-ideal solutions, and there will be elevation. Suppose if we draw here, again the same. So the two components here, there will be the mole fraction, and so if component vapor pressure on the two, here XA is equal to 1, XB is equal to 0, here XA is equal to 0, here XB is equal to 1. So here this the vapor pressure, and again the dotted line indicates the normal vapor pressure, and so there is the elevation, there is the elevation, or there will be the depression, there will be lowering. So as it is maximum boiling, it means more temperature, so the vapor pressure formed here, children see here, it will be lower. There will be they experience the lowering in the vapor pressure, and so these are the two cases. And so here if we take the standard condition, and here there will be, so this is the graphical representation for the maximum boiling azeotropes. In case of minimum boiling, just it will be reversed. In case of minimum boiling, here it is the minimum boiling. So in case of minimum boiling, there will be the condition like this. Here there will be the mole fraction, and here as it is same, XA is equal to 0, XB is equal to 1, here XA is equal to 1, XB is equal to 0. So vapor pressure on this axis, vapor pressure on this axis, and as a result here we have this type of representation. And so here there will be elevation, there will be elevation. So these are the vapor pressures of individual components, and here and the, so this is for minimum boiling azeotrope. So this is how they behave each other from their normal conditions, and so this is all about the azeotropes and azeotropic mixtures or azeotropic solutions.